Hello. Welcome to this session of the HackAtom. Um, I'm happy to be presenting here. This is a great initiative. We had past HackAtoms, and we had a lot of things that were created in the past that today they're just like amazing things that are in production in the ecosystem. So I'm happy to be presenting a session today. And the focus today, we're going to be talking a little bit about IBC and also Hermes, which is a relayer. And then we'll take from there. We have probably around 1 hour. I'll leave some minutes at the end for Q&A. So let's get started. I'm going to share my screen. 1 second. And perfect. So today we're going to talk about the Hermes relayer and how it's helping connecting IBC-enabled blockchains. As most of you know, the idea behind Cosmos is to connect blockchains, and IBC is the protocol that enables that. But in order that to function, you also need a piece of an infrastructure called a relayer. So a little bit about myself. I'm currently working as a developer advocate and software engineer at Informal Systems. I've been with the ecosystem probably a little bit over 2 years now. Before Informal, I was with the Interchain Foundation. I was the grants manager at the Interchain Foundation. But once Informal was created, I came back to my technical background and start helping the IBC team develop the relayer. And today I'm also helping to be as a developer advocate, helping the ecosystem and developers out there. You can find me on GitHub at AndyNog or at Twitter and Nog Dev. So Informal Systems, it's one of the core entities at the Cosmos ecosystem. We are developing software to support Cosmos, mostly on IBC, like with the Hermes relayer. But the interesting fact is that we are also doing a lot related to the trustworthy, verifying the code and software. We have a part of the business other than like doing software development. We also do formal verification. We have experts in TLA plus, in model-based testing. And our CEO is Ethan Buckman, who is one of the co-founders of the Cosmos with Jay. And we are hiring. So if you're interested, you can go informal.systems/careers. We have a bunch of positions open for software developers. We have positions for operations, business, researchers. So if you want to be part of the family, just go to the website. And like I said, from a software development perspective, we're helping a lot with the infrastructure for this interchain. We are very focused on implementations based on a programming language called Rust. So a lot of our code base, it's built in Rust, which is an amazing language for building this type of infrastructure. So some of the repos or projects that we have is the Tendermint RS, -RS. The -RS is basically kind of like a naming convention. When it's a Rust project, we tend to name a -RS. No particular reason, but it's just to demonstrate this is implemented in Rust. So the Tendermint RS it's more like a project that it's used by another code base, which is the IBCRS. So this is kind of like the most important thing that we've been doing. And IBCRS has a bunch of components like IBC modules and also the relayer, which we call Hermes. And IBCRS also uses the Tendermint RS as a dependency. So we have all this infrastructure that we've been working on for quite some time now, and a lot of this are in production today in Cosmos. So today the agenda is going to be, like I said, we don't have a lot of time. Just trying to do a short intro to IBC. I know, like, from going around and people asking questions, still a lot of questions about how IBC works. I can't, if I had to do like a deep dive on IBC, it probably would take me at least 5-6 hours to do at a reasonable level. So the introduction here is just to show some abstractions and building pieces of IBC. So next time you're going to play or you want to understand IBC and see, sometimes it looks like magic, but it's not. There's a bunch of things behind the technology, right? And then we'll try to do a quick demo of like transfer tokens between chains using Hermes as the relayer for that. And then, like I said, at the end, we'll leave some time for Q&A. So IBC. So what is IBC? Before we talk about IBC, we have to understand, let's say, in the blockchain world, it all started with all these blockchains being created as independent blockchains, that they wouldn't communicate with each other. They wouldn't be able to transfer things between them. And in the Cosmos case, these blockchains, any people can take the SDK or using software to create their own blockchain. And the interesting thing about the Cosmos blockchains, they're sovereign, right? So each one are independent. They have their own governance, and people have their own software. They can do updates differently. But at one point, it's interesting that we want them to exchange value or exchange information or communicate, right? So how can we do that? Like blockchains, they can't communicate directly to each other, right? I can't plug into, let's say, make my blockchain A talk to blockchain B directly, like establish a connection. Like, for example, like you have, let's say, TCP/IP that I connect like a client server type of connection, right? So in order to allow them to, let's say, communicate, you need a relayer. What we call it, it's kind of like a messenger, right? So the relayer is this middle piece that sits in the middle that allows these blockchains to be communicating and exchanging messages, right? So you can plug them, and once there's this connection between them, then they can transfer information from one to the other. And the relayer is the one who's responsible to understand what's going on each side, and also be transferring the messages that these blockchains are sending. And this when you say messages, is basically, let's say, transactions that are happening between them, right? So within those transactions, you have messages, and the relayer is responsible to be, let's say, relaying those, right? And in the end, what happens is that it all started pretty small, with probably Cosmos Hub being the first IBC enabled chain, probably back in, I would say, around April or so. So there's the big Stargate upgrade around around February, and then after that, with the Stargate upgrade, you had like the IBC module as part of the upgrade, and then there was some governance proposals to enable IBC, and that would allow chains to start connecting as long as they also supported IBC. And that started pretty small, But this is a snapshot I probably took a few days ago. You see now we have more than 20 chains connected. So each between each chain, those lines are connections between these chains, and you can see it's quite nice if you go mapofstones.com. It's an amazing site to see the flow of information between these chains, right? And every day you get a new chain. I'm just wondering in a few years how this will look like. It's amazing to see this progressing and all these chains. Like I said before, they are like sovereign chains, but this is I think that one of the most interesting aspects of Cosmos is that chains are independent, but they in this let's say mutualistic behavior, they want to connect and exchange value. And eventually this value transfer between chains is going to probably create amazing use cases and things that as far as I know other blockchains are still struggling to come to this scenario, right? So the other interesting aspect of IBC eventually is that IBC is not let's say a protocol that is tied directly to Cosmos. In fact, one of the things people are looking now is to implement IBC as a protocol on different chains, for example, Substrate or other chains that would allow this communication. So it's more like a TCP/IP protocol that once these other blockchains implement, it would even one day possibly you could see a non-Cosmos chain at this map here. That will be quite interesting. Maybe, who knows, next year sometime. So there's quite amount of working going on that direction. So let's go back a little bit and start talking about, like I said, the building blocks of IBC, right? So in order to understand how this communication with IBC is possible, you need to understand some of these abstractions, right? First thing is it's the IBC clients. So to illustrate that, there's a kind of like a few type of clients, let's say. So let's talk about a little bit about what are like clients, right? So in Hermes, as you see, as this middle thing, the thing in the middle, Hermes uses like clients to communicate with the chains, right? And understand what's happening with the chains. So a like client is basically a mechanism that the like a software or something that can communicate with a chain without having to validate the whole blockchain itself, right? That's why the reason it's called like client. It can verify the chain, but without having all the information in the chain. I don't want to go too much into the specifics how that is accomplished, but just to be aware that this is something that it's not a particular thing for Cosmos. It's like blockchains. The different blockchains might have different like clients. It's just a way to allow, let's say, a client type of software to communicate with a full node or a chain that has all the information. At the bottom, I just put the command that would you would use in Hermes to start like let's say a chain relaying, but I want to just go through everything until you understand what's behind this command, right? What's going to happen once I start. So I can do Hermes start, and I can start the communication between these things, right? So the first thing that happens is that a client, so in this case, as you see, we call an IBC client. So each chain needs to have somehow a form of, let's say, bit tracking the information on the other chain. So in this case, you have a client of chain A in chain B, and an IBC client in chain A, a chain B client in chain A. So this is the default. This is when these clients are created, the chain assign a name, and usually it goes like 07 is the Tendermint client, and 0, you see 0 on the left and 1 on the right. It means that doesn't necessarily mean it's going to be like 0 and 0. It depends on how many clients already exist on a chain, and the chain will be upgrading this sequentially, right? So once you have the connection, the client, you need a connection, right? So within that client, a connection is going to be created. A connection is also an abstraction within the client that would allow this communication to happen. So you see here on the left-hand side, you have connection 0, and the right-hand side, you have connection 1. And in order for this to happen, there's a lot of messages that get exchanged between those two chains, right? So I'm hiding a lot of complexity, but just to give you an idea, in order for that two connections to get established, you need to have some sort of what we call handshakes, right? So as part of a connection handshake, there are like different messages were exchanged. This graph this slide diagram might be sometimes overwhelming because it's a lot of things going on. But as you see on the top, these connections can be initiated through like an operator or the relayer itself. In the case of when you do relayer Hermes start, this will be the whole handshake will be handled by Hermes. But just keep in mind what happens is there are like 4 messages: a con open init, open try, open ack, and open confirm. And the states are tracked on each chain, right? So you see that like on chain A, the starting point is that you have none and on. So there's no connection between them. As you go through these messages, you start opening the connection. So once you do open init, chain A will have an init state, while chain B is still none. But then you do an open try. It moves from an init to none to a init try open. So those are kind of like changing the connection states every time you send one of these messages. Until the end, like you see color-coded from like red to green means like at the end, what you want is to have a open state on both chains. So once you have that, basically you have that connection established between the two chains, right? Another thing that you need on top after you have the connection is what we call channels, right? So in order to have a channel, it's the same idea. There are going to be some handshakes, and also a channel. As part of these channel establishment, you also have what they call a port or port ID. And in this case, let's say for fungible token transfers, it's called transfer, right? So that's why you see at the command line that you have you specify the port transfer, and your channel is channel 0, right? So this is the most important thing, is the channel and the port, right? Having that is going to be key to a lot of things in IBC, especially for token transfers. This is used as part of the denomination of the tokens. We'll see a little bit more about later on. But basically, it's kind of like the path, right? Channel 0, transfer / channel 0. It's kind of like the path that goes to channel 1, transfer, right? And same as the connection, you also have a handshake. And the handshake, the idea is the same, but just the messages, instead of being like a con open init or channel open init and channel open try, but is the same workflow between I would say, the connection and channel. And at the end, what you want is to have that open state between the two chains, right? Once you have that, then you have a channel established. This is when you actually can, if you have token transfers enabled on your chain, then anybody could use that channel to transfer tokens, right? Another thing that we have to understand is that once you have the connection established, what you can transfer packets, right? And the concept of packets in IBC is that eventually you can transfer any type of packet, right? So IBC has some, let's say, applications that the first type of packet that we're doing, and this is what you see today, is the what we call the fungible token transfer, right? So basically, you can transfer one token from one chain to another chain. And so within that packet, what we have inside it depends on the application how to handle the content of that packet. So what it would allow me to do once I have that connection established is I want to transfer 999 tokens from chain A to chain B. I could do that, and Hermes, and that transfer could be initiated in different ways. It's basically a message that you can send. So today, I could, and we'll see at the demo, I can use Hermes to do one of those transfers if I have the channel established, or this could be through a client or a wallet or anything that can send this type of messages on an established channel. Through IBC. So once this is transferred, this will get on the other side. So a lot of people get confused on how this works and what is this and what's behind this. So just to illustrate that, the packets also have some sort of a handshake, right? So you're sending from chain A to chain B, starting with a transfer message, and then chain B will issue like a receive message, and then there's acknowledge. So there's this kind of like three-way handshake that happens when you want to transfer some tokens between chains. So just to illustrate and how the in the case of a fungible token transfer works is, let's assume you have some tokens in chain A and you want to transfer those to chain B, right? So a use case would be you have atoms in Cosmos Hub and you want to transfer them or deposit them in Osmosis, for example, right? And get like atoms in Osmosis. This is a typical scenario a lot of people do, and they can use the interface in Osmosis to deposit, but behind the scenes, this is probably what's going to happen, right? So you have the tokens. The tokens will move to the other side, but what chain A does is that they'll scroll the tokens and say, okay, I'm sending tokens from my side to chain B, so I'm just going to keep it safe here. Say I have this tokens in the scroll, send to chain B. Once chain B gets that, there's going to be like a mint type of behavior that will generate like a voucher, for example. So when you say voucher is because this is one concept that you have to understand in IBC is that the native tokens that you have in Cosmos Hub are not necessarily real atoms per se that you have on Osmosis. It's kind of like a voucher that you have to say, I have this, let's say 100 atoms that I got here that I can guarantee that they're being scrolled in the other side and I can use here. And one day, if I want to send them back, what I have to do the, let's say, opposite transfer or reverse transfer. And those vouchers, they'll get burned on the chain B. And once they get burned, you can unscroll them on chain A. So now you have your atoms back on chain A, right? So this is how, at a really, really high level, just to give you an idea how these fungible token transfers work, right? So what we can do now, we can do a little demo, just showing how this works, right? So this is very simple. I'm not going to get too much into details, but the demo itself, it's a very simple demo. We're going to have two chains called Earth and another one called Mars. And then what we're going to do, we're going to send some Earth coins to Mars, and we get those coins at Mars. And the satellite in the middle is just a funny way to say this needs to be kind of like the relayer. This needs to Mars and Earth needs to have some sort of communication between them, so this transfer can actually happen, right? And in order for us to create the chains, I just used Starport to create the Earth and Mars chains. If you don't know about Starport, it's an amazing software that really allows you to scaffold chains quite easily. You can have your chain up and running in a few minutes, and you can do online, you can do locally, and it abstracts a lot of the Cosmos SDK development. Actually, there are a lot of today live blockchains in Cosmos that were created using Starport. It was created, so Starport is developed by Tendermint Inc. And they've been doing it. I've been following them for quite a long time. I've used in past demos. It's quite nice to help out. So you should definitely check Starport, starport.com, to find more about it. If you want to run the demo, you don't need to, but if you want to explore like a Rust language, you can install locally. This is just in case you want to kind of like clone and compile the code base itself. If you don't, you can always download the binaries. There's executable binaries for different types of environments. So, but if you want to start playing, or you want to see how things works in Rust, or even use one of the, let's say, IBC modules, or the Tendermint RS and start playing, this is where you get the software. And the repo is, so we have most of our code base, like I said, is under in GitHub under Informal Systems /IBC-RS. So this is part of the, it's kind of like a mono repo where you have different things in here. The most important thing is a folder called relayer-CLI. This is Hermes, right? So this is the command line interface for the relayer. But if you want, you can always go to releases. The latest release is the 08. And you can download the binaries there. So if you don't want to bother getting Rust, you can just go and get one of the binaries from there. And in Rust, you also have this concept called crates. So crates are packages, kind of like in Node.js, you have npm packets. In the Rust world, we call those crates, right? So the Hermes is published as the IBC-relayer.-CLI. This is the crate's name, and this is something that you also can use if you want to. So in order to do the demo, I created. I'm gonna make this available shortly after the hackathon. So you're gonna be able to use the same files that I'll be using for the demo. And if you want to play locally, you're gonna be able to. So it's gonna be under Informal Systems /Hermes-hackathon-demo. Okay, so let's go to our demo, right? So those are the files that in that repo that I just mentioned. So I have two folders. I have chains and I have a relayer folder. Basically, like I said, the chains are Starport chains. They're created with Starport. Like I said, the nice thing about Starport, you can use, let's say, configuration files, and then when you bootstrap your chain or start your chain, there's a bunch of configuration you can do in there. So in this case, and on my Earth chain, I have two accounts, one for Earthling and one for Tellurian, and I have a fixed address for the Tellurian. And I'm going to explain why I need that. It's because I'll need those accounts to be used by the relayer. While I'll go through the demo, it will make more sense. But the idea is that a relayer, in order to submit transactions to each individual chain, they need some tokens, because every time you need to, let's say, pay for a transaction, you need to have tokens to pay for those, right? So you, one of the things, aspects of running a relayer is that you need an account with some balance on the relayer side that allows these transactions to be happening, right? And one particular thing, detail, is that once you start, Hermes is just listening for all these events, and if there's a transaction that it needs to do, it will just execute, right? So everything is autonomous. So you need to ensure that you have some balance, that you can be running Hermes for some time. And then I also have the Mars chain, but idea basically is the same idea, right? And then I have the relayer, where I have some files in here that it's basically some scripts and some of the keys that I'm using here. And you see, I need the mnemonic, and don't worry, this is just like a local chain. There is nothing, no money in there like real money. They will probably get some, like I said, if you see the Tellurian, we have the Earth coins, or E coins. They'll get initially 10,000 of those. And then on the Mars chain, you're going to have two guys, the Martian and the Green Man. The Green Man is going to have 10,000 M coins or Martian coins. And so the mnemonic is just a way that I can import this key into the relayer side, so the relayer can sign the messages and use the money to pay for the transactions, right? Okay, so let's go here, and I want to go back here. So I have a few things. So like I said, this is the folder where I have all my Starport Earth chain. So what I'm going to do, I already have Starport installed. If you don't, just like I said, go to starport.com. And Starport, like I said, there's a bunch of commands and things like that. It's a very, actually, Starport has its own relayer built in, but we're not going to use, in this case, we're going to use Hermes, but you could even use its built-in relayer to start testing things, right? And you can scaffold not only chains, but also modules, messages, queries. It's very powerful. I would definitely take a look. So what I'm going to do first, I'm going to start my chains. I'm going to do Starport chain, I think start, serve, and then I'm going to start that. It's going to do a bunch of things. It will be build proto files. It will install dependency. And here I'm going to do the same things, Starport, chain, serve, and I do -f. -f is just to force to restart the state. I've been testing with this, so I want to make sure, not Starport. Sorry, my mistake. So it resets the app state and start the chain from scratch. So this is also a nice thing. So if you're building a blockchain, you want to start really go crazy and start testing, and you don't want to bother about keeping the state, you can just use that, right? So the chains will be starting to take a little bit of time, install some dependencies, and while it's doing that, we can take a look at a little other things here. So once I have that, what I'm gonna do, I have some scripts in here. I'm gonna just add the I have this command that passes the mnemonic, and basically what I want to do, I want to just add the keys, the Tellurian keys to the earth, to the key ring of that. So I'm gonna go back in here. So this earth chain has started. You see there's some endpoints where you can reach, like the RPC or the API for the chain, and you see here some accounts were created. So this one, Dirfling, because I didn't specify anything, it generates like a brand new account with a mnemonic, but this is just used as a validator for the chain to kickstart the chain. But the other one, the Tellurian, is this one. I just need to go in here, and I need to import the keys, right? So what I'm gonna do, I'm gonna go earth and then set up key, and then it's just doing the mnemonic. And now what's gonna do is gonna do a keys add and recover. So we uses the mnemonic. And now I'm gonna list the accounts. So as you see on earth, I have the two accounts, right? The Earthling and the Tellurian. And now I'm gonna do a change, Mars. I'm gonna set up the other account, which is the green main account. So I have both accounts now on each key ring for each chain, right? And if I go back to Mars, Mars is also started. Same thing. I have like a Martian here and a green man. So everything should be fine for now. One thing, so let's start looking at the relayer, right? So the relayer now, what I'm gonna do, I'm gonna start setting up the relayer. So before I do that, I just wanna show you one thing. So Hermes relies on a config or configuration, right? So this is part of Hermes. Every time you use it, you need to have this sort of configuration. And the most important thing about the configuration is actually the chains that you specify. So in my case, I have all the information for the Earth chain. So it's basically the endpoints that you have, they're listening. And those ports should match the ports that you have in here. So the RPC port, I believe is the gRPC is the other one. So just make sure that you get the ports that you're using on those chains, right? If you specify different ports other than the default ones for your Starport chain, they need to be here. And there's other things like the key name is the Tellurian, the account prefix. So so as you've seen, in Starport, I could change the account prefix. So my addresses, if you go back in here, my addresses start with Earth. So it's an Earth address instead of being like in Cosmos, you have Cosmos something. Here is Earth, and in Mars, same thing, Mars something. So you're specifying here. The other things are mostly default things that I just left there. So we need this config in order to start doing things. And every time you run a command, you will need that. So in my case, I have just like some, oh, I'm already. So step one. So I have a script to do the setup. Basically, first thing I need to do, like I said, I have that file with the key. So I'm going to import that into Hermes. And so I added the first one. So this is the account that I will use to submit transactions to the Earth chain. And then I need one for the Mars chain, the Greenman. And if I list both, so I'm just listing the accounts in here, and I see they are configured in Hermes. So Hermes has these keys list in the chain. So you just to make sure the accounts are there. So the second most important aspect now is that I'm going to open a channel. Because I have the two blockchains running and listening here on this endpoint, so what's going to happen is that Hermes is going to submit a command. This is the command to create a channel between Earth and Mars. And the ports on each side is going to be transfer. One interesting aspect of the command is that you don't specify the channel name. This is, like I said before, this is something that the chain will be responsible to provide, right? So you'll get a name, you'll know what's the channel name, and probably it's a sequential number. So because this is the first time I reset the state of the chain, so it's probably going to be channel 0. So as I type here, you're going to see a bunch of things happening with Hermes, and it will do a bunch of things. This is basically the handshake that I was saying. Remember, we mentioned in the beginning, it has to create the clients, it has to create the connections, it has to create the channels with the port, and do all the handshakes, like the connection handshake, the channel handshake. And once everything is good, we can see this last message in here. You see now that I have the channel success, and I have on channel ID Earth. I have a client, like I said, client 0, Tendermint 0. I have a connection 0 on a transfer, and a channel ID 0. So basically the same as we had in that diagram, right? And on Mars chain, same thing, because it didn't have any channels or anything. The name will be the same, but again, it's on a different chain, right? So once I have this channel established, what I can do, I can start relaying with Hermes, right? And in order to do that, I just gonna do the start command, and Hermes will take care and will be listening to this thing. So if you see it, there span some workers and things, and it's kind of like in listening mode right now, right? So we have now established the two chains and the relayer in the middle, listening for things that transactions that might happen. So before I send like a token transfer transaction, what I'm going to do, I'm going to just show one thing here. I want to show, I'm going to check the balances, right, on each chain. Commands I can execute to see that, so you know that things will change after the token transfer. So I'm going to query first. I can use the chain executable EarthD to query for the bank balance of the Tellurium account, right? So if I do that, I see, as you saw in the config, I start with 10,000 Earth coins. And now I'm going to query the Mars, the green man, and he has also 10,000 M coins, right? You see, both accounts, they have the native tokens. There's nothing special. There's no anything other than there's a stake token, but the stake token, it's used in this case for staking, and also it's being used by paying for transactions. As you see, I started, I believe, with I don't know, it's a big number, 100 million stake. or 200 million here. The green man is actually 100 million. So you see the number going down. And the reason this number is going down here is because the relayer is using stakes to pay for transactions. So I could have like two coins, one for staking, but another coin, which is actually a real coin, right? And that's the one that we're going to transfer. And I also have a command that is called denom trace. So denom trace, you can, I'm going to query the Mars to see if there's any special thing. And so far, there's nothing. It's an empty thing, right? So let's see what happens when we do a token transfer, right? So let's do that. Step 3, transfer tokens. So I'm going to transfer some tokens from Earth to Mars. So I want to remember that diagram in the beginning. I want to send some e-coins to Mars and try to visualize that thing that we're talking about, the fungible token transfer, about the scroll and the mint and the voucher and things like this. So the command, like I said, you could do this in different ways to submit a transfer transaction, but Hermes provides a command in order to do that. So we can do what they call a TX raw FT transfer. So it basically submits a message transfer from Mars. Sorry, this is the destination chain and the source chain. So we're transferring from Earth to Mars. Transfer channel 0, the one that we established, and how much you want to transfer. I'm going to send 100 of the denom e-coin. There's also other things that parameters like the timeout height offset. So this is something that you can specify, like a timeout in seconds or in heights. So in a blockchain, if the whole thing doesn't happen in that timeout that is specified, you want to kind of like reverse transactions. So IBC has mechanisms to revert things if things don't go well. So you might have seen, like, if you use IBC transfers in Osmosis, for example, and you try to transfer it, it takes too long, and the money eventually goes back to the source chain. So there's mechanisms about in IBC to detect like timeouts and then revert back. So the original tokens are freed up on the source chain. So let's see what happens when we do this, right? Remember that the relayer is listening in this side. So far, nothing's happening. He's just listening. But I'm going to execute the command, and it was pretty fast. Hermes is pretty fast. It's actually the most used relayer in production today at IBC world. But let's try to see what happened here. So there's a bunch of messages, right? That it's kind of like that handshake about like receive and acknowledge, and then and at the end you have a success and packet, and then some specification what that happened, right? So in order to check that, okay, before we do that, let's see on the relayer side. So you see on the relayer side, there's a bunch of things that happen here too. So you see a lot of messages about transferring, and then at the end you have client as updated. Oh, so this is one important thing. Another big aspect of Hermes is that every message that it sends, it does what we call a client update. So this is part of the IBC security model to be ensure that the client, those IBC clients on each chain are in sync and the trust levels are fine. There's a lot of logic between those things, but the most important thing is to understand that if you open a channel and you want to keep the clients, the IBC clients, up to date, you don't want them to be, let's say, closed or clients that cannot be used anymore. So that's one important thing to be mindful in IBC, is that you need to be doing transactions in these things. So what happens is, let's say we want to check now. The best way is that if we check the balances again, right? Remember, everything was the default, but now I'm going to check the Tellurian Earth. And what I would expect is that my 100 Earth coins are not there anymore. And indeed, it went down by 100 e-coins. And so it was scrolled somewhere, and I don't have that in my balance. But if I check the green man, I can see that it got like 100 tokens of this IBC / a big thing. So this is what we call the voucher, right? This is a representation of those 100 Earth coins on my chain. And if I show the genome trace now, here, you see that I have this on my Mars chain. I have this eCoin path transfer channel. Remember, we're talking about that it's very important, that path, the port and the channel. It's because it's used. So basically, what this kind of like represents, this big hash, it's kind of like this. It's something saying, on this path, transfer channel 0, I got something called eCoin. So this is the equivalent of eCoins on my chain. And the reason why is that eventually you want to transfer this back to the other chain. Eventually, the destination chain needs to know the path to send those things back. So as an exercise, because I just looking at the time now, as an exercise, I'll leave to you, if you want, to do the transfer tokens back from Mars to Earth. And what you would expect is to see the same balances the first time I run this script. So the Earthlink should get back into 10,000, and this might still show up, but will show up with 0, because this is something that got created on the chain. So just the balance will be updated, right? So this is the demo. I know it's very quick. Like I said, 1 hour is to talk about all these things. It's really short. One thing that you can do is check the Hermes guide. It's at hermes.informal.systems. It's a very good guide that it talks a lot about Hermes, how it works. There's some tutorials that you can do. The nice thing, you can do a tutorial that pretty much kind of like is the one that I said I showed here. You start relaying, but you can also do raw transactions. If you really want to understand the handshakes, you can go and you can execute those individually. So you see all the steps that I had on the diagrams, like the open states, init, confirm, all those things you can do here. And then you can relay packets. And even the relay packets, you have commands to see how this handshake works, right? So check it out. There's also a big commands reference here, how to use it. Yeah. And let's go back to PowerPoint here. So some takeaways. Like I said, you can play, you can use this. But to do a full relaying service in production, you need a lot of DevOps, chain ops. So that's what we call, like at Informal, we have our, let's say, as part of the family, there's a validator called Cephalopod Equipment that they do a lot of relaying for the Cosmos ecosystem today. So a big part of you see the map of zones, all those connections. There's a lot of things happening behind from an operations perspective that people take for granted. So kudos to those guys who are supporting the interchain. And really understand how IBC works, like you need, like I said, the specific thing about like clients and things. You don't want to be using your channels to transfer tokens unless you understand how it works. But this is a good thing, so you can use a local testnet or local relayer to play with things, or if you're developing your own chain, to ensure that eventually one day if you go in production, that will work well with a relayer such as Hermes. In Discord, you can find some help here. And like I said, the guide is over here. So I'll go into questions. Let me go back here. I'll stop sharing for now. I don't know if there are going to be any questions. But like I said, if you need some more information about Hermes, best place to go to the guide, people on Discord. If you have questions about operations, you can also get involved with validators who are doing the relay. But other than that, yeah, thank you very much. Thanks for attending, and hope that this gives you a good overview about IBC and how the interchain works, at least at a high level. So next time you do a token transfer, at least you know a little bit more what's going on and what's happening. Yeah, let me see here. I think there are no questions for now. So I think that's good. We are just out also about time. And again, yeah, that's a good point. If questions come up later, there's a Discord HackAtom. So if you're not on Cosmos Discord, you can join. There's also a bunch of channels specific to each technology or each chain, and you can ask questions in there. All right. Thank you very much. Yeah, I see some guys, some comments, participating in Game of Zones. Yeah, that was quite a nice exercise that we have with the Cosmos ecosystem. All right. Thank you, guys. Have a good day.